So I think that this is the last speech before the conclusion. So I'm not very high skill like what we have done at C, but it's more like playing with SDR. And I want to share you my experience about developing funny thing with a little board, which is the Raspberry Pi. I see that there is a lot of user and a lot of SDR people use this low-cost SDR, RTL-SDR, about 10 to 20 euros. So it's not a very high cost to try to play with something, which means that the idea is also that there is a lot of users, makers, or schools using Raspberry. I think it's more than 10 million sold right now. So why not trying to make some radio with that? The first thing I see is the Pi FM, which was developed to transmit some frequency modulation. I think maybe 3 or 4 years ago, and I was very interested in that because I don't know how they can manage to do that only with one wire. Output from the Raspberry Pi. There was no documentation on that, which means that we have the source code, but there is no mechanism explained how it works. So I take some time to analyze the code and really try to understand how it works. And after that, there is a guy who is a P1NNZ. I never succeeded in reaching him by mail, but he wrote a little article about making SSB with the Raspberry Pi. So it was again something that I analyze. So I tried to first to show how is Rpitx. It's not very easy to pronounce it in English. In action, which means that how it works in general. Then trying to share with you how I implement it using the Raspberry Pi and what could be the future evolution. So there is some example of what we can do with the Raspberry Pi, but I can maybe have a little video, which is very short, that I publish on YouTube as soon as I have the Rpitx working. There is no comment and not documented, and it was just a strange thing on the web. Just to share you and try to explain you at the same time at the video. So here I have a remote control ring bell, okay? So it's on ISM band, and I just record the IQ signal, and then I record the IQ signal with the RTL-SDR dongle, and then with this IQ file, I replay it, only replay it with the Rpitx. The spectrum is not the same, not exactly, but the ring bell is okay to understand the signals. And so it rings. And this is the end of the video. So you have the comment with the video, but on YouTube there is nothing on that. So we can do well. The main purpose is to have a very low cost transmitter comparable to the very low-cost receiver, which is the RTL-SDR. The range is about DC to 300 megahertz, but you can have more if you use the harmonics, and there is a lot of harmonics. So you can make some FM, SSB, SSB with not very good quality. I explain why after that. Make some spectrum painting, and even make some 3 centimeters transmission using HB100, which is normally a Doppler module, which is about $5, and using the IF to use the mixer of this module. And then I can transmit even television on 3 centimeters with that. So what is Rpitx? It's mainly, well, a software, a command line for now. I try to implement a library after that, but and the only thing you have to do is to plug an antenna on the GPIO and with filtering, if you want to make an antenna after that. But if it is in local, the output of the Raspberry Pi is about 10 milliwatts, and it's not a lot. So if you have just a little wire, there is not a lot of power going to the shortwave. So what is in as input in the command line? It's a file or a pipe, so you can stream in real time. The file could be IQ, or other modes. I will just explain after that. You need to specify the frequency you want to transmit and the sample rate you want to transmit. The sample rate for now is maximum 500 kilosample. So it's reduced bandwidth. It's not comparable with all the real SDR platform. It's a game. It's just to begin. So there is some limitation, of course. So how to feed this Rpitx? Well, the common way is the IQ modulation, so coming from several other software to do that. With the Rpitx, I make some sample of very common modulation, which is AM, FM, SSB, FSQ, which is a digital mode. I implement 1 month ago the Opera, something like that. And you have also another mode, which could be done with the IQ, but if you want to do this very easy, it's a frequency and a timing, which means that if you want to make a FS key, you just have to say, okay, I want this frequency for a period of time and another frequency at this period of time. And this is the same with the AM with timing. Then you can do easily OK, which means that you transmit the carrier, then you wait without any carrier for a certain time, and then again. So it's other 2 modes, which is convenient to go to transmit. There is other possibility to feed it. Well, use IQ, and thanks to Andreas that we see the presentation before, who write an application note on Rpitx using, and it was amazing for me, because I think he provided this maybe just 1 week or few days after I released the Rpitx. So here you have a GNU Radio TCP sync, which means that the IQ is sending to the network or local IP, and then the Raspberry Pi get it and transmit it. And you have also a CSDR example from Andras. But you can have also a GUI, thanks again to Andras, to have a transceiver, which means that you have RTL-SDR for reception and just the Rpitx on transmission, so you have a transceiver. And you can use, it's not really ready, but you can use SDR Angel from Edouard, F5OEO. It's a complete SDR with plugin, and there is some networking and messaging between the both, so it's very interesting. And I try also to have a Pi SDR driver, which means that could be used by other software, third-party software. After that, if you want to really transmit on amateur band, for example, we have some. We need absolutely some filtering. Why? Because the output of the GPIO is 0, 1, so it's TTL 3 volt. So as it's square, then you have all the harmonics, which could be useful if you want to have a higher frequency, of course. So here it is in action. It is the harmonics, and after the filters from HS7 DCD, which is this one. Just plug it in on the Raspberry, and then you have a filter and a little amplifier. This was designed first to make whispering, but you can use it with Rpitx without any problem. If some interest, there is 2 modules to win after the conference. There is other solution. There is G7 CKF filter fit, which is not, well, I didn't test it right, and there is some other filtering from other company or kits, something like that. You can do, of course, your own filters. So this is how it works, or how I try to implement it. So the first thing with the Raspberry Pi is that the peripheral and all the registers are well documented. That's not the case with the other chip, well, competitor from Raspberry Pi, which are not very easy or not have enough PLL description to do that. So I mainly use the Broadcom 2835, which is the engine of Raspberry Pi. So the main component, well, I have in mind is the PLL, which is the clock, and we can make some PWM frequency and DMI, and I will explain you quickly, I think. For the PLL management, which means that what frequency I want to do, we start with the main clock of the Raspberry Pi, which is about 1.2 gigahertz. And then you have all the divider. So if you want frequency, you need to compute what is the divider of this main frequency. But this is integer divider, so you can't reach all the frequency, which means that you have some step between frequency. Then you can have also a little rest if your frequency is not integer, and then it's used, well, it's like a PWM of frequency, which means that with the integer divider you have F0, F1, and then we switch very fast. If we want the middle, we switch very fast the two frequency and try to have the center one. The issue with that is that you will have a lot of harmonics again, and I can show you it. Here is the first mode of this PWM of frequency, and there is a lot of spurious. This is another mode which try to randomize how you put F1 and F0 and F1, which means that if you always say F0, 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 then F1, 1, 1, then you will have a lot of spurious. If you try to randomize it, it's better. But this is there is a better resolution, but not enough, which means that if you want to be at 1 Hertz, it's not enough, depending of the frequency you want. The more your low frequency, the more you have higher resolution. So I implement the same mechanism, but by hand, to switch between frequency 1 and 2. So now we know how to have how to set a frequency output of the GPIO, but we need a sample rate, and the sample rate very important to have a constant, which means that if you are at 100 kilohertz, you need to really, because you compute your IQ, your sample at this frequency, you need to have a very precise time. The issue is that even on Linux, it's not it's not determinist. Okay, so we need another method to have a precise timing. This is done with a DMA. So the DMA is normally to transfer memory from one peripheral to another, or RAM. But we can try to feed PWM, but it's not used as a PWM. It's just for timing, which means that we try to output sample, and as you have set the PWM overclock, then you have a constant bit rate, a constant bit binding. For the amplitude, it's another story, because, well, we have no DAC here. We just have a frequency. But there is a buffering, which means that you can modulate the amplitude of the GPIO buffer, and you have only 3 bits. So we have just a very limited dynamic. So we can make some modulation, well, amplitude modulation, but only of 3 bits. We can try to make the same method with the frequency, which means as we have 3 bits, if we want the middle of 2 bits, then try to PWM this. The problem is that you will have a lot of spurious. So how can we have a cleaner signal? And is it good to is it good to have hardware on that, on top of that, as it's very simple? So I think it's very popular because you don't need anything. We can use something which is a DAC on Raspberry. Yes, there is quite a DAC on the Raspberry, which is used with the VGA. Well, there is a little module like that, which is called VGA 666, and which use only air-to-air ladder, which is a DAC, and then you can have an analog signal on here 6 bits. So it's, and you can have this at up to 250 megahertz. So it's a solution, and then you have to send the IQ over a screen, like a screen. So you have to work with a buffer, a video buffer. So that's an evolution. You can see that I produced this SAW filter with this method, but I will not go further for now. Well, I didn't. You can use an IQ modulator, which is done here for, well, this is a card which is for transmit digital TV. Because what I didn't say is that before developing Rpitx, I developed RPRDA TV, which is a digital television modulator without any other thing. You don't need any, well, it's the same, very simple. It's a DVB-S, so not DVB-T2 or something like that, so a more simple modulation, but it works like that. So here, it uses the IQ modulator, so it's another project. And well, we use AD8345, which is just a quadrature modulator. We can use maybe a mixer. That's done by one guy here from Spain. And because we can have high resolution frequency, and we can mix after that. Or drive transistor, which means that feed transistor with the PLL, so no amplitude, and only the drive, only the drive done by air-to-air could do that. So this is the current working. There is a lot of inspiration. There is a lot, so we can't see all that. But this is the reference, or the lot of guys I look very closely. And well, for the conclusion, well, this is a conclusion from a guy. I just published the software, and there is a lot of comment on that. And well, I try to experiment and to share my software, and some people think that it's not a good thing to share, even it's bad, because I think that experiments could be some very bad product or good product, but we have to share it to know the issue that the other have, and so. So in conclusion, I think that we have to experiment, share, and make all that better. So what I propose you is to contribute even on the software, but also on the electronic part. And because I believe that the community is the power. So I propose something. I'm not very good at software. I'm not very good at RF. The SDR is just the beginning for me. But I think that we can learn from all the community. Thank you.